All right, like I mentioned yesterday, I am gone, obviously, again today. And so we are looking at 5.1.3 as we continue to look at inverses and finding them. Earlier this week, we looked at finding them graphically. Now we're going to go back to kind of the algebraically. And this is probably one of the more practical ways of being able to do it. I apologize, I don't have my AirPods today, so you're going to get the tapping of the pencil on the iPad. But hopefully you can work through it. So today, 5.1.3 is we look at the inverses algebraically. Starting with the table, we're looking to write an equation for this. And so I'm going to give you a few minutes, pause the video here, see if you can work through 5-40, which kind of walks you through the steps of what you need to do. And then I'll come back through. So pause the video here, and then we'll go through it. So as I look to write an equation, I'm looking at how I'm going from my x's, which is a little bit hard because we're going by 2 each time, to my y's. Okay, but hopefully you are able to come up with the equation y equals 6x minus 11. If we plug those in, 6 times 1 minus 11 gets me negative 5. 6 times 3, 18 minus 11 gets me 7, so on and so forth. Okay, we've looked at creating these tables as well of the inverse, and this is really easy, right? We're just switching. So my inverse table is how my x's and my y's have just switched. So I have negative 5, 7, 19, 31, and 1, 3, 5, 7. Okay? So how are these tables related? I feel like we've talked about this really quite a bit. All we are doing is our x and y's are reversed. Okay? So it says then use this relationship between the tables to find a shortcut for changing the equation. And we looked at this as we looked at our graphing, right? This kind of shortcut is that we are just, again, switching our x and y. So instead of y equals 6x minus 11, I now have x equals 6y minus 11. And now we're looking to solve this, okay? And so I'm going to just do this underneath. Add 11 gets me x plus 11 equals 6y, and divide by 6. So I have y equals x plus 11 over 6. And this is my inverse. So I could say f of negative 1 of x is x plus 11 over 6. And we could justify this by plugging in a number. Pick a number. Let's say we picked, let's just do like 3 and 7. Okay? So if I plug that into my original, I have 7 equals 6 times 3 minus 11. Okay, or 7 equals 18 minus 11, 7 equals 7. Okay? And if I flip this, right, so now if I plug this in my inverse, I'm doing the opposite, so I'm plugging in 7. 7 plus 11 over 6 should equal 3. 18 over 6 equals 3. 3 equals 3. Check. Okay? So you're going to do this then to find the inverses of each of these. So again, pause it. Some of these get significantly harder, but we know how to undo all of these. So I'll give you a second and pause the video, see if you can work through these 4. So again, your first step is you're just switching. I have x equals 2, y minus 1 cubed. Okay? And now I'm just kind of trying to work backwards to get y by itself. So I'm going to divide by 2, gives me x over 2 equals y minus 1 cubed. I'm going to take the cubed root on both sides. Gives me the cubed root of x over 2 equals y minus 1. And lastly, add 1. So my inverse is y equals 3 cubed root of x over 2 plus 1. I think I'm going to work down here rather than across, but you can do whatever. Again, pause it now after you've seen one. Maybe try the others on your own. Switch your x and y. And it's just kind of testing your skills, really. So we're going to subtract 20. x minus 20 equals 3, y minus 9 over 2, divide 3, x minus 20 over 3 equals y, get that there, minus 9 over 2, times it by 2 on both sides. Careful here. We have 2 parentheses, x minus 20 over 3. You could clean this up a little bit, but we're just going to leave things kind of messy. And we get y equals 2, x minus 20 over 3 plus 9. I'm going to actually do b last because this one does have a little caveat to it. So as we look then at D, again switch, 4/3 y minus 1 cubed plus 6, subtract 6, 4/3 y minus 1 cubed, multiply, this one's a little tricky, by 3/4, and that cancels this here. Go 3x minus 6 over 4, y minus 1 cubed, cubed root both sides, get the cubed root of 3, x minus 6 over 4 equals y minus 1, and then 1. 5y equals the cubed root 3, x minus 6 over 4 plus 1. And our last one here, again, this one is a little bit different, tricky, perhaps. You get y minus 2 plus 3, subtract 3, x minus 3, square root y minus 2, square both sides, and just pause this as you need to. I get, x minus 3 squared equals y minus 2, add 2, and I get y equals x minus 3 squared plus 2. Now, like I said, this one does have a restriction though because of parts of it not being a function. So here my domain has to be x is greater than or equal to 3. And we'll talk about that when I get back. Okay? So hopefully you're doing a nice job with that. The last part here then of today's lesson is kind of how we can do this and check these rather quickly and easily. So this last part gets a little bit confusing, but try to stay with me. Okay? It says Adriana's strategy for checking that the function f of x and g of x are inverses is to think of them as a stacked function machine. She starts by choosing an input to drop into the f of x, then she drops the output from f of x into g of x. If she gets the original number, she's pretty sure that the two equations are inverses. Okay? So as I look here, we would say this is my function, this is my inverse. Okay? So my input of 3, which is what she just picked, okay, comes out with an output, and that output turns into an input into my inverse, and I get back 3, okay? And so this, and the first one says, is Adrian's strategy sufficient? Okay? She really should check both ways, or in both directions, okay? So then run it in reverse as well, okay? It says, with your team, select a pair of inverse equations from problem 5-41, then name them f of x and g of x, then use Adrian's ideas to test them. So I'm going to kind of do this with a calculator to make this a little bit quicker. You can pick any one of these, so pause it, try one. I'm not sure really which one would be easier or not. I'm going to pick A, so pause it, try it with A. So if I try it with A, I have f of x equals, this is a example, I have 2x minus 1 cubed, okay? And we're saying this is my original function. So if I go f of 3, that means I have 2, 3 minus 1 cubed. And I'm just going to plug that right in my calculator, okay? So I have 2 parentheses 3 minus 1 to the third power. Boom. gets me 16. Okay? So then in my g of x, which is my inverse, right? G of x, we said the inverse, and we calculated this in A to be the cubed root of x over 2 plus 1. Okay? So now I am plugging in g of 16, right? That's the 16 here. Gets me the cubed root of 16 over 2 plus 1. And again, I can really just type this in my calculator. Math gets me the cubed root. 16 divided by 2, outside the cubed root, boom, plus 1 gets me back to 3. Okay? Again, you should check this the other way as well. I'm not going to take the time to do so. Okay? So, we'll lose the calculator for now. We'll probably bring it back later. It says, Adrian wants to find a shortcut to show her work. She knows that if she chooses her input for f of x to be 3, she can write the output as f of 3. Next, f of 3 becomes the input for g of x, and her output is 3. Since f of 3 is the new input for g of x, she thinks that she can write the process of g of f of 3 equals 3. Does her idea make sense? Why or why not? Yes, this is how you would write it. And I'll write it out what I said. This would be g of f of 3 equals 3. Okay? Her friend Samantha thinks she could also write f of g of 3. Is she correct? This one is no. G of 3 can't be input for f of x unless reversed. Will this strategy for test inverses work with any input? Like, do we have to pick 3 or can we pick anyone? Okay? We can put any input. So she picked 3, we can pick 20, whatever. Okay? Now, Statler, Adriana's teammate, is also looking for shortcuts. He thinks he has a way to adapt Adriana's strategy but wants to check with his team before he tries it. If I use her strategy, but instead of using a number, I skip that step and put the expression f of x directly into g of x to create g of f of x, will I still be able to show that these equations are inverses? Okay? So, here is what we are kind of going to do, and I'm not necessarily going to follow these, okay? But if I go and do g of f of x, okay? So if I take one of my g of x functions, so let's continue with a, okay? So I said g of x is equal to, this is example A, we said the cubed root of x over 2 plus 1, okay? Now I'm just going to write these here so we can work. And my f of x is 2x minus 1 cubed, okay? So this gets messy, but it does kind of help provide a shortcut. So I'm going g of f of x, or I am taking this and I am putting that in for x, okay? So I have the cubed root, or g of f of x, is I have the cubed root of 2 over x minus 1 cubed over 2 plus 1, okay? Now, we have to clean this up a little bit and this tests some of our skills. Here, my 2's cancel and I'm left with the cubed root of x minus 1 cubed plus 1. Well, a cubed root of something cubed, again, cancels. So I have x minus 1 plus 1. And lastly, negative 1 plus 1, combining these is 0, and I just get x. So g of f of x gets me x. And this is always true with inverses. And we actually could run that backwards and do f of g of x and should get the exact same thing. Questions? I guess you can't really ask questions anyway. I'm just in the habit of saying that. And then our last one that we are going to do today, it says trio says that if you know the x-intercepts, the y-intercepts, the domain and range of a function, then you automatically know the x-intercepts, y-intercepts, domain and range of the inverses. Hillary disagrees. She says you know the intercepts, but that is all you know for sure. Who is correct? So, again, we'll talk more about this when I get back, but trio is correct, but this assumes the inverse is also a function. And we will stop there for today. Okay? I should be back in full swing next week. Sorry, it's been kind of a broken week here for me, but I'll be back full swing next week. And so today, for the weekend, your homework, and we'll have a homework quiz next week, is 5-48, 5-49, 5-51, and 5-53. Have a great weekend, and we will see you